Okay, good afternoon everyone. I'm the first panelist for today, Amar. This second panelist, Shreethar. Third panelist, Dinesh. Fourth panelist, Danish, and fifth panelist, Vishal. Okay. Alright, now that everyone is here, let's get into our main topic for today, which is identifying the best AI model for quality assurance in robotic manufacturing. The goal is to evaluate two major contenders, visual vision transformers, which are widely used in advanced computer vision tasks, and vision autoencoder like Vision AD, which are becoming popular for anomaly detection. We'll look at accuracy, speed, deployment, maintenance, and overall reliability for our robotic production environment. So I will ask Shreethar to tell the problem statement.
Thank you, Amar. For quality assurance in robotic manufacturing, our requirements are quite strict. First, we need extremely high accuracy because even a small defect like a scratch or minor alignment error can compromise the performance of a robotic arm or actuator. Secondly, we need real-time inference. Our assembly lines move really quickly and we can't afford delays. The system must detect issues in milliseconds. Third, the model has to be robust to environmental variations. Factory floors have inconsistent lighting, vibration from nearby machines, and reflections from metal surfaces. Fourth, we need scalability. We often introduce new robotic components, and the model should adapt without needing months of retraining again. And finally, the system must run on edge devices like Jetson or industrial PCBs because uh, real-time cloud processing is too slow and too expensive for high volume quality assurance.
Given those requirements, the first solution I want to put forward is Vision Transformer model. A VIT Vision Transformer model are currently the strongest architecture when it comes to computer vision, and because they are using the self-attention mechanism. How the mechanism works is it allows the model to consider relationship between each patches. So in robotics QA, this is very beneficial. We deal with complex assemblies, wires, joints, sensors, and so on. The relationship between these parts are very important. Another major strength is global context. Transformer treats the images as a sequence of patches and it can analyze the whole image and find relationship between them. This means micro defects that occur in contacts like a misaligned connector or uneven surfaces are more accurately detected than the normal CNN. VIT also handle lightning variations. For example, the camera and the lightning variations. Sometimes the lightning will be very bright. Sometimes it won't be like very dark. So the VIT is better at that. In factories, shadows and glare are unavoidable. But because the model sees the whole image simultaneously, this inconsistency don't degrade performance as much. Even the accuracy is pretty high. Explainability is another big win. VIT produces attention heat maps, which shows exactly where the model focus and where the defects are. So it's easier for us to look at the defects, and for robotics QA, I think it's very helpful. What do you think, Dennis?
I completely agree with the Vision Transformer recommendation. I'd like to expand more on the benefits. One major advantage is that VITs are excellent for high resolution images, which is exactly what we need in robotics QA. Industrial cameras often run at 4K or these days even 8K resolution. So for inspecting components, CNN tend to struggle with very large size images. Uh, so we can because they break them into tiles, which can cause models to miss defects that span across the tile boundaries. VITs handle high resolution images much more naturally. Another great feature is consistency across different camera angles, camera setups. If we switch cameras, upgrade lenses, or modify lighting in a new production line, for example, VITs maintain accuracy and reliability more reliably than a CNN model. That gives us long-term stability without constant recalibration. Also, because VIT models, the entire structure, the excel at identifying geometric inconsistencies, like warped parts or bent pins, mispositioned screws, all of which are common in robotics manufacturing. So from the perspective of long-term performance, scalability, and robustness, vision transformers are an excellent fit. What do you think, Vishal?
While vision transformers are powerful, I believe a vision autoencoder based model, like efficient AD, for example, would actually be a better fit for a real robotic manufacturing environment. The biggest advantage is that efficient AD requires very little training data. In manufacturing, we usually have thousands of images of normal, non-defective parts, but very few images of actual defects. Efficient AD thrives in this scenario because it learns the pattern of what a perfect part looks like and then flags anything unusual as an anomaly. Second, efficient AD is extremely fast. It outperforms many transformers and CNN models in inference speed, which is a critical for real-time QA, is designed for industrial environments where every millisecond counts, just like what Shreethar said earlier. Third, efficient AD is easy to train and maintain. Instead of needing labeled defect datasets, we train it using only good samples, which dramatically reduces the workload of the dataset. This also makes the model more flexible during new product launches. Another key point is reliability. Efficient AD consistently ranks as state of the art on industrial defect benchmarks, especially in anomaly detection settings like uneven textures, scratches, missing components, or manufacturing variations. And because it is lightweight, we can deploy it as on multiple edge devices simultaneously without requiring expensive GPU upgrades. So in my view, a vision autoencoder solution gives us speed, simplicity, and high reliability, all with much lower cost. What do you think, Arnold?
Those are very strong points, and I'm inclined to agree with efficient AD suggestion. One thing that stands out to me is how well autoencoder handles low-level environment. In robotics manufacturing, we don't have the luxury of thousands of defects. Example, especially for new components, the ability to train purely on normal images is a major advantage. I also like how efficient AD adapts to new robotic parts with minimal training. When we introduce a new actuator design or sensor module, we can train the autoencoder quickly using all the normal production samples. Another benefit is that anomaly detection models tend to be more sensitive to subtle deviation. Instead of being told what is defective, the model simply identifies anything that doesn't look like it. For quality assurance, this reduces the risk of new defects type slipping through unnoticed. And lastly, lower hardware costs is a practical factor. Since Aviation AD doesn't need heavy compute power, we can run it on our existing edge device across multiple production lines, making it cost effective for scaling. How about you, Shreethar?
Um, I agree with that direction. The point I want to elaborate is on the data requirement. Like Vishal mentioned earlier, the defective part of robotics are very hard, and we can't afford to purposefully break a Danish part just to train the model, because that would require a lot of damaged part, and it's not profitable for us. In that direction, efficient AD, it only trades on normal images and flags anomaly cases like how Vishal mentioned earlier. In robotics QA, defect samples are rare and expensive to capture. Efficient AD's ability to work with only normal images removes one of the biggest obstacles in industrial machine learning, the difficulty of collecting labeled defect data. What do you think, Dinesh?
I will add to that by emphasizing edge deployment efficiency. Efficient AD can run smoothly on injection or industrial PCs with some CPUs. So we don't have to upgrade our hardware. The GPU cost is very expensive nowadays. If you use CNN or even Vision Transformer, we have to upgrade our GPUs. So the cost is very high. And by using the Vision autoencoder, we can reduce the cost. At the same time, we can increase the profit. We can detect the defects for cheaper price. And this is critical because upgrading hardware across all production lines would be extremely costly. That's my point. What do you think about it?
After looking back at everyone's points about the Vision autoencoder, I do think that it's better than Vision transformer. One point that highlighted me the most is Amar's point about uh, that how easy it is to adapt to new parts. So the scalability is important here. As we diversify our products, as we are a robotics company, so there's going to be a lot of changes and evolution throughout time. uh, we diversify the products, the ability to quickly retrain an anomaly detection model is very crucial here, as we do not want to wait weeks just to be able to do quality assurance once again. So that is what highlight is highlighted to me the most.
Okay, great point from everyone. So as conclusion, it's clear that while Vision Transformer offer high accuracy and strong global feature extraction, we all agree that practical advantage of efficient AD, which has low data requirements, fast inference, easy of deployment, and excellent anomaly detection, make it a stronger and more scalable solution for our robotic environment. So Action AD stands out as the most suitable choice for our quality assurance pipeline moving forward. Okay, thank you for your time. Okay, thank you.
All right, thank you.
Thank you.